Okay, today we're going to be starting 3-5. And if you hear me when I say we're starting 3-5, because I've split 3-5 up into 2 days. So part of the reason is if you look at all the different standards, which I know you probably don't pay a lot of attention to these, and that's okay. But all of these standards, it's just a lot to do in one day. And because we're also writing equations, these are very, very important in the field of math. Whether you want to go on to math or not, equations come up in almost every single course. And so it's really important that you practice and you take your time on these. And so I've split the lesson up into 2 days. So for today, we're going to just be looking at what are the different formulas and how to write them. And in the second day, we're going to be looking at a lot of things with distance. So I know that's kind of a review, but also perpendicular bisectors. So in a way, kind of right now, we're just kind of doing sort of the first two. We'll touch a little bit on the third one, but mostly just the first two, okay? So in our lesson today, we need all of this information. So really, we have two different forms. That's kind of the key piece. But these other three topics come up in those as well. So first, slope formula. And if we were together, I would be asking you what it is, but since I'm all alone, it's y2 minus y1 over x2 minus x1. I should also say that really nothing in this first part of the lesson is new. So in day one, I would consider this a ton of review. But I will tell you in day two, it's going to be new. So if we try to put the two together, you might just feel overwhelmed. And plus we have the time to take it slow, so we're going to. Okay, so slope-intercept form is y equals mx plus b, okay, which is something, again, I know you've seen before in many of your classes, so that shouldn't be anything new for you, okay? Point slope you learned in algebra, but you might have forgotten it. So we have y minus y1 is equal to m and then x minus x1. Now remember, x1 and y1 is just a point on the graph. So this is just a point. It doesn't have to be the intercept up here, okay? All right, now, if we have parallel lines, we want our slopes to be the same, okay? So we want our slopes to be the same. If we have perpendicular lines, we want our slopes to be opposite, reciprocal. And let me just give you an example. Let's say our slope was 1/2, okay? If it's parallel, we would want our slope to be 1/2. If it's perpendicular, we would want it to be the opposite, so negative, and then we would want to use the reciprocal, 2/1. So that's kind of how slopes relate, all right? So in this first picture, what they're going to do is they're going to give you some different lines, and they're going to ask you, are they parallel or are they perpendicular? Now in class, I'm going to be assigning different rows, different lines. So I'm going to say like, okay, this row you get A, this row you do B, and so on. So I don't necessarily want you to do all of these because it's 4 of them and it just takes a little bit longer, but I want you to go through at least one of them with me. So let's do line A together. So I'm just kind of highlighting it so we can see it better here. Now, oftentimes I get asked which one is the first and which one is the second, and honestly, it really doesn't matter. So let's just call this the first ordered pair, and this would be our second ordered pair. Now, you don't have to write this. I'm only doing it so that you can follow along. It doesn't matter which one you do first. So if this is my first and this is my second, I'm going to do the second y minus the first. So 3 minus 2, and then I'm going to go 0 minus a -3. So notice how it zip-zapped. So if I work this out, I get 1/3. So that would be my slope. Now, because this is in the picture, yes, you could count. You could go up 1 over 1, 2, 3. But if you look ahead at the next page, what you're going to notice is there is no graph. So sometimes it's good to get used to the slope formula, but if you want to count, we can count too. So if we take a look at B, here's line B. Notice I'm going to go up 1 over 1, 2. So up 1 over 2. Let's do line C. I'm going to go up 1 over 1, 2. So I'm already noticing something really nice about those. All right, let's do line D. Now we got to be careful because line D is going the opposite direction. So line D, I think I'm going to have to use this ordered pair and this one. At first I wanted to use an ordered pair lower, but they don't really give me one. So let's use those two ordered pairs. Now notice that this is a negative line. So when we count, we want to count down, not up, because this is a negative line. So we're going down 1, 2, down 2, so down 1, 2, over 1. Or we can use the formula, which we're going to do quite a bit of here in just a minute, okay? So what I'm looking for is which lines have the same slope and which lines have opposite reciprocal. Well, I'm noticing that A has no relation to anybody, so I'm just going to completely ignore A because it doesn't have a relationship. But I'm looking at these other ones. So notice B and C are the same, so those are going to be parallel. Notice B and D are opposite reciprocals, so B is perpendicular to D. I'm also noticing that C is opposite reciprocals. Now what you don't want to do is you don't want to go like this, because that tells me all three of them are perpendicular, and B and C are not perpendicular to each other. So you don't want to do like a big string of perpendicular. You want to kind of do them individually. So notice C is also perpendicular to D. And then one quick thing as well is it doesn't matter if you reverse these. So for instance, if you would say D and then B, that's the same thing. It doesn't make a difference as long as you have the same two letters together. Okay, so I just want to point that out. Okay, so if we move on to the next page, which this is actually our last page for today, because remember, we're splitting this into 2 days, but this still has a lot of information in it. Notice in the next two examples, we don't have a graph. Now, yes, you could go get graph paper, but they want you to practice the formula. And then if you notice in 4 and 5, they give you the equation, okay? So let's just take it one at a time. We'll do number 2. We need to calculate the slope. So I'm going to use this as my first and my second. So I'm going to start 4 minus 4 over negative 5 minus 3. So that's 0 divided by negative 8, which is 0. And it's okay to have 0 on the top. Okay? It's okay to have 0 on the top. It's when you have 0 on the bottom that it's bad. So this is okay. All right, now we're going to go negative 2 minus 9. And then we're going to do negative 1 minus a negative 1. So we have negative 11 over 0. Ooh, that's the bad one. That's undefined. Now we have to think about this though. What does a slope of 0 look like? A slope of 0 is a horizontal line. That's a slope of 0. What does a slope undefined look like? That is vertical. Now, it doesn't matter where I draw this at. That's kind of irrelevant. What matters is how they come together. And these two come together at a 90-degree angle. So the question is asking me is determine whether the lines are parallel, perpendicular, or neither. These are perpendicular because they come together at a 90-degree angle. So you have to be able to look at the slopes, the answers, and then use your knowledge of the definitions to formulate your answer. So why don't you pause it here and try number 3. Okay, on number 3, for this top one, I would go 7 minus negative 1, 2 minus a negative 2, that's 8 over 4, which is 2. And then I would do 5 minus a negative 5, 2 minus a negative 3, that's 10 over 5, which is 2. So I'm noticing these are the same, so I would say this is parallel. Okay? All right, 4 and 5. If you notice on both of these, they look very similar, line 1, you know, so on, so on. But notice they're giving you the equation. So you have to know how to pull the slope out of these. Let me jump to number 5, line 1. This is in slope intercept. In slope intercept, the slope is right in front of the x. So my slope would just be 3/4. That's a pretty easy one to pull the slope from. What you're given over here is what we call standard. So in standard, I'm going to write it at the top. Standard is when your x and your y are on the same side. Now, it doesn't necessarily have to be x first, but if you're going to use the shortcut, you have to do opposite the x value, so the value in front of the x, over the y value. Now, if you don't like this shortcut, what you could do is you could solve it for slope. You could put it in slope intercept. So what you could do is you could add the x and you could divide by 4 or by 5. Now, in this particular example, we don't care what the y-intercept is. We only care what the slope is. So we would only care about this number right here. So notice my slope is 1/5. Now, if you want to use the shortcut that I was just telling you, what you're going to do is you're going to take opposite of x, so opposite, which would be positive, over the y value. Do you see how I got the same answer? So it's up to you on how you guys pull slope. But again, you have to know how to get your slope. So this is by far the easiest. And then this is what we call standard. If you look at number 2, it's kind of not really in either. It's not really in standard because the x is not on the same side. But it wouldn't be that difficult to divide off the 5. And we would get 1/5 x plus 7/5. Now remember, we don't really care about this. The only thing we're trying to determine is what is the slope. So in this particular case, the slope is 1/5. Now, you should be at this point probably able to divide this 5 off in your head and know that that's the only number that you really care about. So it's not crucial that you write all this work down. Okay, let's take a look at the third one. Now the third one is back to standard, so it's very similar to line 1. So if it was me, I think I would just do the shortcut. Opposite x over y. Now I need to look at these and do a comparison. So what I'm noticing is lines 1 and 2 are the same. This one doesn't really have any relationship. So for my answer, I would say 1 is parallel to 2. And then I would just be done. Okay? So why don't you pause the video here and try number 5. All right, on number 5, line 2 is actually in what we call point slope. So that's this form. Notice the m is in front of the parentheses. So actually, this one, the slope is also really easy. It's just sitting right in front of there. Line 3, oh, that one's kind of a pain. Because if you want to use the shortcut, you would do opposite x divided by y. So notice that is a compound fraction. But that's okay, because you could go to your calculator and you could just type in, whoops, too many buttons here. So there's my x divided by my y. Now, if you want to kick this back to a fraction, if you don't recognize the answer, if you go to your math key, which is along the left, and then you can just push enter twice. You probably recognize that fraction just because it's pretty common, but if you don't, you can always use your calculator. Then if you look at line 4, I would say this one is a little bit nicer because see how the x and the y are on the same side. Now, they're on the right side, but they're on the same side, so that's good. So you're going to do opposite x over y. So now what you want to kind of look at is there a relationship? Which honestly, lots of these are going to have relationships, so we might have more than one answer here. So how about we do anything that's parallel? So 3/4. Nope. How about -3/4? Yes. So I'm going to say 2 is parallel to 3. But I'm going to put a comma here because I'm thinking there might be another answer. Let's see. Nobody else has the -4/3. So I think the parallel's done. But let's look for opposite reciprocal. So 3/4. If we look at 3/4, the opposite and reciprocal would be -4/3. So if we look through here, I'm noticing this one. So this is line 1. This is line 4. So I'm going to put my answer as 1 is perpendicular to 4. Okay, let's do another one. So we just did the line 1. Let's do line 2. We have -3/4. So perpendicular would be positive, and then flip it over, 4/3. So let's look. Is anybody positive 4/3? Nope. This one would be the same, so we don't really need to test it. The last one, we already kind of know because it paired up with 1. So if we take -4/3 and we do perpendicular, it would be opposite, so positive, and then flip it over 3/4. We already have that one. So these two are our only answers. But notice there was more than one. So you have to make sure that you pay attention to that and that you write down both of them. Otherwise, you would get half of it wrong. And I don't think you want 50%. Okay? The last part of today's lesson is now actually you writing the equations. So now you actually have to write the equations. Most of the time, not all, but most of the time, they'll tell you what form they want. So you'll kind of see here it says point slope or it says slope intercept. So you have to pay attention to what form they'll ask you for. All right, it says write an equation of the line that passes through this point in point slope that is parallel to this. Now, if it's parallel, you want the same slope, okay? Now, point slope is the easier of them to do. It is harder sometimes to memorize, but it is easier to write. Now, you don't have to rewrite this. I'm just doing it so that we have a visual reference here. So this is point slope. This is my x1 and my y1. This is my slope. All I have to do is go through and replace those. So y minus the y value is equal to my slope, x minus my x value. But because it's a -1, I have to zip zap. And that would be my final answer. So if you're in point slope, it's actually quite easier. You don't have to do a lot. You just have to know the formula, okay? All right, let's do number 7, and then I'll have you try one on your own. On number 7, we have an equation of a line that's passing through the point. So we have our point again, but now we're going to use slope-intercept. So remember, slope-intercept is y equals mx plus b. And it's perpendicular. It's perpendicular. Now be careful. We've got to get the slope out of here. So this is in standard. So if we use our shortcut, opposite x over y. That's the slope, but mine has to be perpendicular. So I'm going to do opposite, so it's positive, reciprocal. So my slope is 1/2. Now, if you remember from algebra class, there is 2 ways to do this. So I'm going to show you both ways, and you're going to have to pick, okay? So I'm going to say 2 ways, okay? Method 1 is to find the b value. That's method 1. Method 2 is to use point slope. Now, I have a preference that I'll tell you at the end, but you're going to have to pick. And there are different ways to get the same answer. Okay, so here we go. If we're going to get the b value, we're going to actually use slope-intercept right off the bat. And what we're going to do is we're going to plug this in for our x and our y and our slope. So we have y, we have slope, and we have x, and we're going to calculate the intercept. So if we work this out, half of 2 is 1, we subtract the 1, and we get our intercept. Once we have the intercept, we use our slope and our intercept, and that is our answer. Okay? Now, I'm going to show you the other way to do it, and you're just going to have to decide. If you want to use point slope, you're going to plug your values in just like we did here. Okay? So we're going to go y minus the y value, just like I did there. My slope, which is the same slope, so it's not changing anything. X minus the x value, which is 2, same number. I'm just trying to show you that I'm not doing anything different. Now you're going to use the distributive property. So it's half times x, half times a negative 2, and you're going to add the 3. Exactly the same answer. I kind of like point slope just because I feel like it's maybe about one less line and I can do some of this in my head, like some of the distributing and things I can do in my head. So for me, it's just a little bit less writing, but it makes absolutely no difference which one you pick. You just need to pick. So the final answer is 1/2 x plus 2, but you're going to have to pick your method, okay? So why don't you pause it here and why don't you just try number 8? Okay, hopefully you tried number 8. In number 8 here, we have parallel and we have the slope of 1/3. So that means that we don't have to do anything different with our slope, but you just have to figure out what method you want. So I'm going to use point slope. So I'm going to plug this in, y minus a negative 1. My slope, x minus my x value. I'm going to quick distribute, and I'm going to move the 1 over, and I'm done. Now, if you chose to use the other method, that's fine. I just trying to keep the video a little bit shorter here and not doing both, okay? All right, 9 and 10, the last 2 questions. The reason why I didn't have you do these on your own is because they're just a little unique. So let's take a look at them together. It says write an equation of a line in any form. So this should make you happy, but there's actually a little trick involved. It says that is parallel to this. Well, be careful, because what kind of a line is y equals negative 10? And you should be telling me horizontal. You should be saying that's a horizontal line. So they want you to give an equation of a line in any form that's parallel to this, but passes through negative 5, 4. Well, if it's parallel, wouldn't it look like that? And aren't horizontal lines always y equals? So even though they told you any form, because it's horizontal, there's only one way to pick it. Now, it's passing through negative 5, 4. You don't really care about the x value, but you do care about the y value. So your answer is y equals 4, because it's a horizontal line. Now, number 10 is very similar, so why don't you pause it here and try number 10? And this is our last problem of this lesson. Okay, hopefully you paused it and tried it. You have x is equal to 6, which is a vertical line. Okay, so x equals 6 is vertical. Y's are horizontal, x's are verticals. It passes through negative 1, 9, and it must be perpendicular. So it must go like this. So once again, this is horizontal, and it's passing through -1.9, but because it's horizontal, I only care about the y value. So that would be my answer. Now remember, this is only the first day. Could you imagine if we continued on? Because right now we've only done 2 of the objectives of the lesson. There's actually 3 more. So that's why we split this into 2 different days. But that concludes the first day.